Greetings and welcome, friends. Today we are talking about solving equations with variables on both sides. Both sides of what, might we ask? Of the equal sign. We've so far only been solving problems where all of our variables conveniently were located on the same side of the railroad tracks. And in order to solve when variables are on opposite sides, we're going to have a new technique. Fortunately, just like video games where they slowly increase the enemy AI or difficulty and give you new variation, so is with this math text where we kind of teach you a new type of problem, present a new situation for you to solve. We're just kind of incrementally adding new difficulty over time. So don't worry, I'll be with you here the whole way. We're gonna do fine, gonna be great. So here we go, core concept, solving equations with variables on both sides. Here's what the book says. To solve an equation with variables on both sides, simplify one or both sides of the equation, if necessary. So as usual, if there's distributive property, if there's combining like terms, let's deal with that first, okay? Then, now check this, here's the new part, use inverse operations to collect the variable terms on one side. Collect the constant terms on the other side. Ooh, I didn't even think of saying that. That part, I actually don't even think of that. I think that this would be obvious after step one is done. And then isolate the variable. Okay. Which means to get the variable by itself, right? Okay, so the way I phrase this, all right, when I collect the variable terms on one side, I say this: move the little guy to the big guy. All right, that's my trick. And of course, we are doing it with, like they said, inverse operations. All right, so let me show you this trick. Technically, you can move the big guy to the little guy. The only reason I recommend this is so that we can avoid the possibility of more sign errors, of doing the wrong sign when I multiply or divide by a negative later. It's mathematically legitimate to do it differently than this, so it's fine. But here we go. Watch what we've got. So let's take a look at this first example. So I've got 10 minus 4x equals negative 9x. They are telling me this is an equation with variables on both sides. Are they correct? Yes, there's an equal sign, and I see an x on both sides. So my suggestion was to move the little guy to the big guy, all right? So between negative 4 and negative 9, who has less money if you owe someone $4 or if you owe someone $9? Who is poorer? The negative 9 person has less money than the person who's got negative 4. So I'm going to call negative 9 smaller. Negative 9 is less than negative 4, right? Even though I know it's more influential, it's got a bigger absolute value. Negative 9 is the little guy in my mind. So if I want to move negative 9x to this other side, I can't do that by dividing or multiplying because that x is still going to be there. The way that I move a variable to the other side is using addition or subtraction. So to move a negative 9x, I'm actually going to have to add 9x to both sides. And where do you think I should write this plus 9x over here? Should I write it under the 10? Nah, let's write it under its buddy, under the like term, right? So let's write plus 9x right here. And notice the benefit of what this does. Over here, negative 9x plus 9x, those will undo each other, and I'll be left with 0x's, or just plain 0, right? So I will have gotten rid of the variable over there, and I will have combined them over here. Now, you don't have to box these to do like terms. I already wrote them underneath each other. I know that they're like terms. But let's see. I'll have 10 and negative 4x's plus 9x's. I add the coefficients, and the variable stays the same. So how many x's do you think that will be? Signs are different. Positive 5. Yeah, I like it. Right? The signs were different, so I subtracted the numbers. 9 minus 4 is 5. And I took the sign of the bigger, the more influential one, right? The one with a bigger absolute value, rather. So positive 5x. And over here, 0x's, we'll just write that as 0, right? Because 0 times anything is 0. So now I've got the variable on one side, and this is just like problems we know how to solve already, right? So I've got 10 plus 5x equals 0. Let's get x by itself. Let's move this 10 first. It's a positive 10, so I'll subtract 10 from both sides. That's the part where they said, right, collect the, I already lost my slider. They said collect the constant terms on the other side. We already know how to do that, so I don't think we need to like describe that step or that process any further. Now we just rely on our previous techniques, our previous strategies. I guess I don't have to write a plus sign here. It's just 5x equals negative 10. And so now how do I get x by itself? Divide both sides by 5, right? It's being multiplied by 5. So I'll end up with x equals, well, 10 divided by 5 is 2. 5 fits into it twice, right? But it is negative because there was only one minus sign there. Let's do a check. Now, we haven't been doing checks on all of these problems, but if I was to do a check, if x is actually equal to negative 2, then I'll have to plug it in to both of the locations that x had in the original problem. Okay? When you do a check, don't just plug it into like one of your later steps down here, because what if your mistake was earlier on, right? So you plug it into the original problem. So I'll have 10 minus 4 times negative 2. Is that equal to negative 9 times negative 2? So let's simplify using Pemdas. I'll multiply first. That's going to be 10. Negative times negative is positive 8 in this case, equals negative 9 times negative 2 is positive 18, and 10 plus 8 is 18, which equals 18. Check it out now. Funk is your brother, right? It worked out. It worked out, friends. I found the solution. And the only new strategy I had was move the little guy to the big guy. And remember, the way I move a variable is using addition or subtraction of that entire thing. Okay, so let's get a couple more examples here going. Let's see here. These ones we're not going to take the time to check. All right, where's my mouse? All right, here we go. Here's a couple more examples. So, 2 examples here unrelated to each other, other than the fact that they have variables in math and things like that. Let's see. This has variables on 2 sides. I've got a 3x and how many x's are here for the right-hand side? 1x, right? You could imagine an invisible 1 there, like a hobbit wearing a ring. It was hiding there the whole time. You just didn't know it. And so who's the little guy? 3x or 1x? Which is smaller, 3 or 1? Right? 1 is smaller because these are both positive in this case. So if I want to move 1x, I can move 1x by subtracting that x from both sides. And when I write the subtract x, I'll subtract it over here like so. Underneath its like term. Now, guys, this is the super common mistake. Oh man, I'm just grieving as I hear like a million math mistakes being made simultaneously on a planet. Like the force is just calling out to me here. 3x minus x. Here's the wrong answer. 3. Do you see why someone would have written that? Like what was the mistake? What were they thinking if they thought 3x minus x was 3? Yeah, they were just like, oh, I'm just getting rid of the x. But that's not what we're doing, okay? We have 3x's minus 1x is 2x's. All right, that looks like a weird 2 there. 2x plus 2 equals negative 4, right? So when I add or subtract like terms, I just add or subtract their coefficients. So 3 minus 1 was 2. X is still there. And now I'm just solving this normal sauce, right? Here we go. Subtract 2 from both sides. Watch, I'm even going to solve this quick because you guys are experts at this now. Negative 4 and negative 2 is bigger in the negative direction, so that's negative 6. And then a divide like so. and I'll get x. Oh, it didn't swap colors. Whoa, x equals -3. Right? And so now our problems, I would argue, are getting to the point where we're not going to be able to just look at them and guess the solution. So we're getting to a point of complexity where algebra becomes a reliable process that leads me to the answer consistently, accurately, and efficiently. Okay? So over here we go. I made this one. This one's up a notch in complexity, right? Because I like just like kind of slowly increasing the difficulty here for us. I've got variables on both sides of the equal sign. Yes, I've got a -5x and a +2x. Tricky, not a trick question, tricky question. Which one's the little guy? -5x or +2x? -5 is the little guy. -5 is less than +2. I'd rather have $2 than owe someone $5, right? So -5x is the little guy. How do I move a -5x? I gotta add 5x to both sides. Okay? And the reason I do this is because the number of x's that I have will always be a positive number of x's once I combine them. Okay? So it's just trying to avoid a sign error later. But you could move the 2x to the other side, and you're completely legitimate. You're not at all mathematically wrong in doing so. So I'd have 1 equals 4. 5x plus 2x is 7x. And now I just solve like normal style. Subtract 4 from both sides. Man, there's something just so satisfying about these colors. It's the algebra. Everybody's happy. It's working out. It's beautiful. Beautiful. Divide both sides by 7. And you guys are good with the reflexive property. I'm going to flip this. I flipped it this way, right? Because I like having my variable on the left when I'm all said and done. I'm going to have x equals -3/7. I can't reduce that fraction. Still negative. Oh, that was a sad box. There we go. X equals -3/7. Fractions exist. So we're fine. We're good. We are good. Let me give you one more example. Maybe I think just one. Yeah, one more for today, and then we're going to do part 2 mañana. All right, here we go. All right, this one's already scarier, but that's okay. We don't have to be afraid. I'm with you guys. All right, here's the boss fight of the day. We've got our skills. I see variables on both sides of the equation. However, before I do anything, I've got to simplify. Simplify, all right? So I think that's going to mean distributive property. I'm going to multiply this 3 by these guys. I'm going to multiply 1/4 by those guys, which you could also think of as divide everybody in those parentheses by 4. Same idea, if that helps. So let's see what I get. 3 times 3x, 9x. 3 times -4, -12, equals. Don't let the fractions scare you. 1/4 of 32x is the same as 32 divided by 4. Anyone know what that is? Ocho. Okay, so 1/4 of 32 is 8. All right, and it still is in x's. 1/4 of 56, I believe, is 14. That one I could understand. You might reach for a calculator for that. The way I thought of it was I thought of 60 divided by 4 is 15. And so 56 divided by 4, that's 4 less. So it must have been 1. 4 goes into it 1 less time than that. Another way I thought about it was what was I was thinking? I think I thought 4 goes into 40 10 times, and 40 plus 16, right? 40 plus 16 is 56. 4 goes into 16 4 times. 4 times, and then I end up getting 14. So either way, right? Whether you reach for a calculator, that's fine for now. I want to try to make you stronger in that area. And this is the way you would do math on a desert island when your survival's on the line. You're just like, I got to do some algebra. Let's solve these problems. All right, so now I've simplified. Are there any like terms to combine? No, not on any given side of the equal sign. It's possible you could have had to combine some like terms. That's fine. So I've got to move little guy to big guy. Who's the little guy when it comes to my x's? 8. So that's a positive 8x. So to undo it, I'll subtract 8x from both sides. And let's see, 9x minus 8x is 1x. I could write that 1, or I could just let it be like that invisible hobbit, right? Bam. Where'd you go, Frodo? I don't know. There's not many rings in Moria, Middle Earth, rather, that I can do that, right? I'd be suspicious myself. It's probably a ring of power. I mean, we'll have to test it by fire to know for sure, but let's see, add 12 to both sides, and I'll get EX is equal to 26. So over here was just my scratch work. You don't have to write all that. But yeah, here we go. All right, so I simplified first, and then I solved. But before I started solving, I brought the little guy over to the big guy. And like I said, you could move the 9x over here, and you're completely legit. Completely legit. And in fact, maybe today during the class quest, maybe we'll have you guys try a couple different strategies on the same problem and see which works out. All right, well, thanks for watching, Internet friends. Have a great